Hello and welcome to How Do I BI, a many-part screencast series on the use of SQL Server Analysis Services 2008. This is a companion to my book, Smart Business Intelligence Solutions with Microsoft SQL Server 2008. This is Lynn Langett. I'm a developer evangelist with Microsoft in Southern California. In this episode, we're going to look at how to implement OLAP cube partitions using BIDs. Before we go to the screencast, I'll review the FAQs and gotchas. The first FAQ is that each OLAP cube has only one partition by default, and there is no requirement to have multiple partitions. The most common partitioning scheme, if you do choose to create multiple partitions, is to separate or partition by a date field. You can partition by months, weeks, days, or whatever is appropriate for your particular business scenario. The gotchas around partitioning are failing to set up partitions can result in excessively large cubes, and this is analogous to failing to archive relational data. In fact, it actually has more dramatic and negative results in an OLAP scenario because of the amount of data that you're working with. So improper or inadequate partitioning can lead to excessively long processing times for adding new information to a cube, and also potentially slow query times. Partitioning value has to be correct syntactically in a way that is understood by the source data. So if your source data, for example, is a SQL Server, then it will be a T-SQL query, and that query has to be logically correct to separate the data by the partitioning value. So for example, if you want to partition by months, then you have to have the appropriate syntax to do that properly. Improper syntax can result in data duplication. In addition to this, we'll take a look at the different storage methods, HOLAP, MOLAP, and ROLAP from a procedural standpoint. There's much more to be understood from a conceptual standpoint, and I encourage you to read the sections in my book to understand more fully. At this point, we'll go to the screencast. Screencast, we're taking a look at the use of partitions in an OLAP cube. In order to understand how to do this procedurally, we've loaded the sample AdventureWorks into BIDs, and I've double-clicked on the AdventureWorks sample cube and then clicked on the partitions section in the cube editor. The sample is fairly well designed in terms of reference implementation, and I encourage you to take a good close look at it when you're trying to consider how to set up your partitions in your particular cube. As I mentioned in the introduction, there is no specific requirement to have partitions in a cube other than the default single partition, although it is a very important and a common best practice so that cube processing times and query times are efficient and appropriate to your particular scenario. So if we take a look at this, we'll see that we have partitions defined for the various measure groups which are associated to fact tables. So you can see in the first section here, Internet Sales, we have actually 4 partitions, and the partitions are set up by year, which is indicated in the name. The partitioning value, because the source data is SQL Server, if we pass our mouse over the source, we actually see the SQL query, is set up by an order date key. If we wanted to drill in and verify that, we would simply select on the source column in the partitioning section and then click on the build button to be able to take a look at the source query. And again, importantly, as I mentioned in the introduction to this presentation, this query must be appropriate to accurately partition the data, or you can end up with duplicate data in your resultant cube, which is a logical reunification of all these partitions. The end users just do not see partitions. This is for administrative convenience. Inside of the partition source dialog box, you can see that the binding type has been set to a query here. So you have 2 choices when you're considering implementing a partitioning scheme. The other binding type is table binding. If you wanted to, you could use separate physical or even logical tables views, for example, in your relational source, rather than relying on the accuracy of a query. You'll note that there is a check button in the partition source dialog box, and this really is just to check the syntax. So I'm going to click cancel, and then the other pieces of information that are available inside of this partition viewer is the size of the partition, the number of rows, the storage mode, which can be MOLAP, HOLAP, or ROLAP. MOLAP for multidimensional storage, which is the native and most concise, compact, and efficient storage mode. HOLAP for hybrid storage, which we'll drill into the details in just a couple minutes here, and ROLAP for relational storage. The storage location is set in all these samples to default, If you have the Enterprise Edition of SQL Server Analysis Services, you can define remote partitions for scalability. Also, when you're setting up partitions, you're going to design and implement an associated aggregation scheme, and we'll be reviewing that in the next screencast. The last column inside of here is the status, whether the partition has been processed or is being processed or has an error state. Another important reason to implement partitions is to separate out the processing of a cube, in that if you have older data, archival data for which there will be no new information, it is a good strategy to separate it so that when new data is added to a current partition, previous partitions are not affected. So if I click on Storage Settings link on the Partition tab here, that will open up the configuration dialog box for the partition storage settings. And you can see that we have a slider with several different options going from the default of MOLAP all the way down to real-time ROLAP. If we wanted to, we could just select one of these settings from ROLAP, HOLAP, or MOLAP, and they have to do with latency of information update as well as storage location. Or we could go into the Custom Settings button and then click Options, which will open a child dialog box. By default, when we're set up to MOLAP, all of the general options around caching are disabled because proactive caching, which is a notification of changes from the relational source to the cache of the cube, that's not enabled. If we were to enable proactive caching, then we would have the ability to set our cache settings in certain situations. Notice we're getting a warning here in the dialog box that says the partition is bound to a query and the current notification method is SQL Server notification. In order for change notifications to be received, we need to specify one or more tracking tables to set the notification method to scheduled polling. Proactive caching is available in the Enterprise Edition. It's a very, very powerful and desirable feature. However, it does require additional configuration, as it's telling you here in terms of the metadata and so on and so forth. This would be associated in the second section of the Storage Options dialog box here, which is called Notification. And we would have three options here. We could use that SQL Server table that we're being warned about. We have to specify the particular tracking table that we had set up. We could have client initiated, which would be also associated to tracking tables, or we could have scheduled polling over a certain interval of time, and then we would have to add a polling query as well. We could also enable incremental updates. Again, these options should be used when necessitated by business requirements because they add complexity to your particular scenario. Now, if we were to select a different storage mode from the drop-down dialog in the storage options dialog box here, for example, we could select HOLAP, then we would configure this information regarding proactive caching and notifications as well inside of this dialog box. Also the same for ROLAP. As a reminder, HOLAP stores the aggregations in a multidimensional format and does not make a copy of the source facts into the multidimensional target storage location, as MOLAP does. So it often results in a smaller disk space and can result in quicker processing times depending on how much aggregation you have designed. ROLAP will create aggregations back in the relational source and will also not make a copy of your data. As a general rule of thumb, most of the production cubes that I have used have been nearly entirely MOLAP, at least for current data. For historical data, I have used HOLAP because it does cause you to have a quicker processing time because you're not making a copy of all the facts that maybe you don't access on a regular basis. When we talk about aggregations in the next screencast, we'll talk about the amount of aggregation as associated to the type of storage. So I'm going to go ahead and click cancel out of here and cancel out of the partition storage dialog box. If we wanted to make a new partition for this particular grouping, we would simply click on the new partition link in the partition tab of bids, and then we would be presented with a wizard, and inside of this wizard we would simply click next, and then we would have to specify the source information, which would include the measure group and you can see when I click the drop-down list that all of the measure groups that have been defined in the cube, such as internet sales, internet orders, so on and so forth, are available. And then we would have to define a partition source. By default, we are looking in the data source view, AdventureWorks DW, and we can look at other data source views that have been defined for this particular cube. Then we can select a filter table, and in this case, if we selected fact internet sales, then we would have to specify a query to restrict the rows, and it's suggesting a query for us. Again, obviously this query isn't logically correct. I'm just kind of showing this to show you the procedure of going through the wizard, and in fact the validator is showing me that I have to complete the where clause in order to continue. So I'll just cancel out of this wizard, and it's as simple as that to create an additional partition. Probably the biggest thing that I've seen in real world is the failure to create partitions. As I said in the introduction, it's very analogous, but in a more dramatic way, to the failure to archive in a relational database. It's relatively simple to do, and it will really impact in a positive way your queue processing and your performance. So this is a look at partitions in analysis services.